Well, PC-based software router. Why we need that? We have so many such nice boxes like Cisco, Juniper, and whatever else. It's a question of features and capacity. BGP routing table today, it's something over 650K routes. A prediction for the future, we go to up to 900,000. If we are looking on typical layer 3 switches, they do not have even close to these figures the capacity to store the routes in their memory. So we need something else. How to buy cheap BGP router? Layer 3 switches with 1 gig, 10 gig ports, price from 2,500 US dollars. And they typically support up to 12,000 prefixes, which is not enough for any serious BGP router. And the second problem is that only some of them have BGP implemented at all. They typically have some IGP routing protocol and nothing else. Which means we should go to the classical routers, and their price start from 10K dollars or euros, whatever you like, and they can support full BGP table. But those classes of devices typically do not have 10G ports, which is absolutely necessary if you are talking about big traffic. And the throughput is typically around 2.5 gigabit per second. So we should look for something else. Full feature router, which means it has 1 gig, 10 gig ports. It supports BGP, maybe definitely something else. Performances are 100 gigs and up. It can route 130 megapackets per second and up, but the price starting at 50K euros or dollars. If you're talking about small networks or like IXPs, it is too expensive for us. What is the solution? Alternative solution is to build your own router based on standard PC hardware. Today, standard PC hardware performances are good enough to build an acceptable router. What are the limitations? The limitation is 3 megapackets per second, and it is based on problem in implementation of the kernel and the handling of packets. So theoretically, with that hardware, you can go with up to 20 megapackets per second, etc. But the limitation is the internal architecture of the software. The real throughput, well, this is also the real throughput, but the throughput measuring in gigabits per second can go from 1.4 gigabit per second if you have the smallest packet, up to 36 gigabit per second if your traffic consists of the largest packet on the network. But besides those limitations, it has a very low price. Yes, I can afford that. And we can go with unlimited number of prefixes, which is also good. As you saw with the commercial product, we have serious limitations. What we need to build the PC-based software router? One PC-based server with preferably PCI Express 3.0 slot, and 10 gig interface can work even on 2.0 slot, so you can go with cheaper hardware. Advanced Intel CPU and at least 2 gigabytes of RAM memory, which is not enough for today's hardware. Network interface card with 10 gig ports or maybe 40 gig ports. You can find the cheap one on the AliExpress, Alibaba. We tested with CentOS, but you can take whichever Unix-like operating system. And we are using Quagga, which has Cisco-like CLI. So if you are familiar with Cisco equipment, you can work with Quagga very easily, or go with Bird, which is a newer one with better performance and better features. What we need for a setup? Ethernet port should be configured in trunk mode. Not necessary, but we probably have more VLANs. It's much easier to build your router to get enough functionality to have more virtual interfaces if you are using trunking. Preferably activate IPv6. I think Jan's agree with me. Hello, Jan, don't speak. You should disable network manager services on the kernel just to get the higher performances. Disable GNOME desktop and install PCI utils for load balancing of IRQ interrupt requests. If you do not do that, you will end up with overloaded one core of your processor just handling the interrupt requests from the network interface card. So you must use this. If you need remote monitoring, and yeah, definitely you need it, you should install NetSNMP. For remote access, you need SSH and any additional utility to monitor the router, so it depends on your infrastructure. Just to take as much as possible power from our hardware, we need some network fine-tuning on the PC. So this is the list of modifications that should be done on your Linux-based router. I will not read it. Here it is, so you can check later on. Definitely you need to disable IP tables filtering because it took too much of performances of the hardware, and it will slow down your router, so you will not be in position to get as much as possible from your hardware that you are using. Here is you need to increase the buffer so to be in position to handle so much traffic on your routers. Okay, for the interfaces, of course, you need to turn on the IP forwarding feature and to reconfigure a few other things which is not properly configured for the use of Linux as the router. If we are using VLANs, we should do also some per VLAN configuration of the kernel. Preferably turn off automatic IPv6 address assignment because you need exact IPv6 addresses to define it in the BGP to establish a BGP session. What we have as a practical implementation, we use HP ProLand Dell 180 G6 hardware with 2 Intel Xeon processors on 3 GHz, 6 core per processor. We put 12 gig of RAM, but later on we figure out it's too much. And we put 2 network interface controllers with 2 gig ports, so with total of 40 gig interface. Total cost of this hardware was from $1,000 for server on the eBay and additional $300 for a network interface card. So at the end we end up with $1,600, which is much, much lower than $50K from the brand name router. That's from the side of price. What we get on the network, which is the main point. we reach something about 26 gigabits per second of the throughput of that kind of router. As I said, there are limitations regarding the internal structure of the kernel. There are efforts on the academic community to overcome this, but for now on, we are here. And if you look of throughput in packets per second, as I said, a real limitation is on 3 megapackets per second. We can go up, but if the traffic go over 3 megapackets per second, we notice that the jitter increase, the latency increase, even some packets was dropped. So if you want to use this kind of solution, you should keep up to 3 megapackets per second with standard kernel. If you modify it, you can go up. Total load of the router, as you can see, increased when the traffic go over 3 megapackets per second. Till that, it is almost unnoticeable. So it is handling that traffic without any effort. If you go over 3 megapackets per second, we see a significant increase of the load, and that's the reason why we notice the jitter and the increased buffering of the traffic. The same thing if you look at total load of the router CPU and soft interrupt requests as the main thing that our CPU are working on. Limitations of this solution, as I said, is the 3 megapackets per second. When we reached that, the router started with the jitter and increased packet latency. And the reason for that is packet handling in Linux kernel. There are some works to overcome this. I will mention only 3 things: DPD key, net map, and vector packet processing. You can find those results on the net. Unfortunately, nothing of this is fully integrated with Linux kernel, so none of those projects do not offer fully functional routing software yet, but I hope in near future we will have it. We also tested with 40 gig interface. We use handmade PC server, not even brand name, so go to nearest shop, buy the motherboard, buy the processors. It is Asus motherboard, quad-core Intel processor, and we put 40 gig cards. Everything works for 20 hours, and after that, because of problem with NIC driver, it stopped forwarding the traffic. Reload of the server solved the problem, but you see, if you are using the router, you are not in position to reload every day your router. So till stopping, everything works perfect, and after reloading, it continues with perfect work. What was our conclusion? We got viable solution for the traffic up to 3 megabits per second, and since it is pretty cheap, we can multiply that solution so we can achieve bigger traffic handling. Total throughput in gigabits depends on the size of the packet. Our average packet size is something about 600 bytes, so we end up with almost something more than 20 gig per second. For us, Quagga provides full BGP functionality with unlimited number of prefixes. Today we handle 1.3 million prefixes in our router. And for that, if you are using brand name routers, you should buy a big box. And if you forget the price of human works, because you need a good administrator to install and to build that solution, this solution is very cheap one. That's it. Thank you for your attention.
Do we have any questions? Yeah, we do. Jan?
Just a minute.
Okay, now it works. Okay, I'm Jan. I have a question. Basically, just if you did any tests, did you have a look into the FDIO with VPP for building this stuff?
Yes, I got that information from you a few months ago. Unfortunately, that software is not integrated with the routing part of the. It has just the forwarding, but it does not have a lookup procedure integrated. So you will have Quagga with prefixes, and you have a forwarding engine, and you need to integrate those two.
Okay.
And it is not done yet by the authors, and we didn't have enough time and resources to do that by ourselves. But maybe in the future we'll do that.
Okay, because with that one, so we had Ole Troan, the guy that is programming the VPP stuff in Slovenia a few weeks ago, and he said that he managed to build a PC with 4 sockets, 4 processors, that can do 1 terabit per second of routing. That's awesome stuff.
I was looking on the results of all those projects that I mentioned, and they all get very nice results, but without the lookup module. They just put the static route and then test it. It said, oh yes, I have 1 terabit, but what about routing table, handling different traffic, etc. So it's not integrated yet, it's not yet prepared for the full routing.
Okay, so we know where we need to do more work.
Yes.
Thank you very much.
Definitely.
Next question.
Hi, this is Daniel, Routing Geek. Did you limit yourself to Linux? Did you ever look at things like NetBSD and FreeBSD, which I don't know whether they're better or not?
Neither do I. Okay. We had to find very fast, a very cheap solution. Okay. We just take CentOS, we solve the problem from now on, and that's it.
Okay, good answer. The other question is, if you look at this DPP and the other technologies that you mentioned, I have no understanding of them because I just not followed it. But I read some papers like a couple of months ago that suggest that maybe you would need more cores and more powerful processors to do, and specifically more cores to do forwarding fib lookups in a faster way. I'm kind of concerned that your recommendation, this 6 kernel whatever processor you mentioned there, might be a limitation in the future. Do you have any thoughts on that? Have you looked at those things?
We have enough routers with that we tested a different hardware configuration. We had one router with the 4 cores, but we have another one with 12 cores, which means 24 virtual cores, and the results were the same.
Were the same.
3 megabytes per second, and the limitation is the internal kernel infrastructure.
Yeah, with the current kernel and fib lookups and stuff like that.
Yes.
But I would sort of, if people are going into this and they expect to deploy some of those new technologies, they should probably look at the fact that they might have different requirements. That's all I'm saying.
I agree with
you. Anything more? That would be it.
Thank you.
Thank you.